Hello, I am Mustafa Doğukaan Elikuru. We will be presentation of remote controlled exploration robot project, which we prepared as part LA 401 to 402. Our goal is to design an exploration robot that can be controlled via an interface to reach areas inaccessible to humans, such as narrow space or outer space. This robot is capable of collecting samples using its robotic arm, processing image through its camera, and transmitting the obtained data to interface in real time.
Hi, I am Melikşah. I will continue with the mechanical and embedded part. To ensure the proper connections of the components in our project, we designed the circuit board using KiCad, aiming to eliminate cable clutter. However, due to the change in the components during the development process, we decided to discontinue the use of this circuit board. We completed the mechanical design using Tinkercad and SolidWorks, ensuring it fit to the dimensions of the components. After finalizing the design, we printed the parts using a 3D printer and assembled them. In our general connection diagram, the STM32 board collects data from various sensors and controls the motors. The STM32 is connected to the Raspberry Pi via a UART line. The Raspberry Pi processes images through its camera and transmits data packets received from the STM32 to the interface via UDP. Commands are sent from the interface to the STM32 in a reverse process. One of the key parts of our project is the control panel, which we designed to make the data more understandable using charts, tables, and maps. Additionally, this interface allows us to send some manual controls to the rover. Our commands include motor control, LED and buzzer commands, robotic arm commands, and starting and stopping the image processing process. The embedded algorithm created on the STM32 side was implemented using the advantages of FreeRTOS. We established four separate task structures, which are data handler task, robot arm task, navigation task, and the communication task. The data and variables they share in common were synchronized between the tasks using mutex and queue structures.
We set up a virtual environment on Raspberry Pi 4 and installed the necessary libraries for TensorFlow. We ran TensorFlow on Raspberry Pi's 4-core CPU to ensure fast image processing. We used Google's pre-trained model in TensorFlow, which can identify 80 different objects. The images captured by camera on Raspberry Pi and images marked by TensorFlow are transmitted to interface via UDP. Based on selection sent by interface, we transmit either direct camera images at 30 frames per second or the object detected images 8 to 10 frames per second. Additionally, we receive data from interface via UDP and send into STM32 over UART. The STM32 then sends the sensor readings back to interface via UDP. We perform all these tasks by dividing them into threads, allowing each process to run quickly without affecting others. Now let's watch the general demo video of our rover.
Şuraya götürün ışığa.